So when we're looking at our inside function, not only is it going to be inside of something, okay, there is also a good chance that the derivative of that thing is also going to be floating in my integral somewhere. Okay, so notice like on this one, I have a square root, right? Inside of my square root, I have x squared plus 5x plus 1. Yes? What is the derivative of x squared plus 5x plus 1?
2x plus 5.
Cool. Notice that we have a 2x plus 5. So the derivative of my inside stuff is in there, right? And that's actually going to be very, very helpful here in a minute. Which means that my outside function, I actually don't want to include this 2x plus 5. I just want to include the operation that is happening to my g of x. So notice that that would just be 1 over the square root. Okay? And the reason why it's called u substitution is because we are going to substitute a u in for whatever our inside stuff is. So, like on our next one, what does it seem like our inside stuff would be?
1 plus squared x.
And remember that the derivative of the square root of x is 1/2 times x to the negative 1/2, which is also 1 over 2 square roots of x, which is the square root of x in the bottom, right? So notice that over here I have a square root of x in the bottom. So that is going to be a part of my derivative of my inside stuff. Yes, we're missing a 1/2 there, but we'll look at how to take care of constants here in a minute. Okay, which means that 1 over, I have a cubed this time, so u to the third would be our outside function. Somebody asked second hour why the dx was up top. So remember, we usually like multiply by a dx. However, most of the stuff that we've dealt with hasn't been fractions. Okay, so like it's just off to the side, like that first one is. But a lot of times, if I just have a 1 up top, they'll just write the dx on top, so that way like it's not as long. So it means the same thing. Okay, it's just the dx is on top. All right, what do we think our inside function is for the next one?
Wait, wrong one.
So what operation do I have there? That's kind of on the outside of the parentheses.
X to the power 3 over 4.
Yeah, it would be u because we don't leave it as an x, but yes. So we have u to the 3/4 would be our outside function, which means that our inside function would be the x to the 4th stuff. Which also makes sense because what's the derivative of x to the 4th plus 2x squared plus 7?
X cubed plus h.
4x cubed
Or 4x.
plus 4x, right? So notice that both of those have a 4, but if I take away the 4, I get x cubed plus x. So again, we have an extra constant, but that's not going to be super hard to deal with here in a bit. All right, what about our next one? What do we think our inside stuff is?
X plus 4.
Which means what is our outside stuff?
X over square root u.
So we're not going to include the x.
1 over square root.
Now we do have an extra x, so we would have to take care of that a different way, but my outside function would just be 1 over the square root of u. What about our next one? What's our inside part?
X squared plus 1.
Which means what's our outside part?
U to the 9.
Alright, so what do we think about that? Because we have to get used to like recognizing what they look like before we can actually like do the use of. Yeah.
So this is to solve the definite integral, or
Well, these are all indefinite intervals. you can do them with either definite or indefinite intervals. It's just basically intervals that have stuff on the inside that would have had to, like I took the derivative using u sub. Because otherwise, like right now, we don't have a way to solve that with any of the other techniques or rules that we've learned so far. Yes? So it's just like another rule. Just like we had to learn the chain rule, we had to learn the product rule, we had to learn the quotient rule so we could take the derivative of more things. I have to learn u sub so I can take the antiderivative or integral of more things. So let's look at it. So we have the integral of 2x times x squared plus 1 quantity squared dx. So what do we think our outside function is?
U squared.
Correct. Which means that in order to rewrite it, we want the stuff on the inside of the squared to be u. So what we're actually going to do is come over to the side and we're going to say let u equal that inside stuff. Or allocate with how we picked which one was what. Alright, but notice that right now in my integral I have a dx, which means that I'm taking the antiderivative with respect to x. We're switching everything to u's, which means that I need a du now instead. So if I have u, how do I get du? By taking the derivative. So the derivative of u is du, but if I take the derivative of one side, I must also take the derivative of the other side. So what is the derivative of x squared plus 1?
2x.
2x. And why might that be helpful?
Because that's how it's all the time.
Yeah, so it is technically dx, right? Because I took the derivative with respect to x. So notice that this 2x dx, I now have here and here. So those are going to become our du. So I have u squared, right? Because I substituted that, and then my 2x and my dx become our du here. Which is very helpful because if I look at the beginning, having x squared plus 1 squared, I don't have a way to take the antiderivative of that. But now I just have u squared. Do I have a way to take the antiderivative of that? Yeah, it's just a basic power rule. What is the antiderivative of u squared?
U cubed over 3.
1/3 u cubed
Plus C.
plus c. Now the only thing that we have to do at the end is because this is an indefinite interval, okay, I'm not plugging any numbers in, but since my original interval had x's in it, my answer also needs to have x's in it. So we're going to substitute back in what that original was. Now, technically, okay, because this has u's, this constant is actually different than what this constant is that has x's, but we still just label them both as c, because we don't really care. Because they're both just constants, and so it doesn't really matter a whole lot at the end of the day. But I sometimes have people, but like, isn't this c different than that c? Yes, but we just leave them both as c. Yep.
So would there be a time where like the derivative doesn't match?
Yes.
What would we do there?
We're gonna look at an example. Hey, so what's my inside stuff?
Squared 7 plus 9.
7x plus 9.
X plus 9.
Yeah, it's gonna be our inside stuff, yes? Which again, I need it to be a du instead of a dx, so I'm gonna take the derivative. What's the derivative of 7x plus 9?
7.
7. Do I have a 7 there?
No.
No. So what do I wanna do? Do I have a dx though?
Yes.
Yeah.
Yes.
Okay. So do you agree that eventually I can substitute stuff in for my dx. Bless you. Yes?
Would you divide by 7?
Yeah.
So du over 7 is du.
Yeah, usually we write it as a fraction though. So now when we rewrite this, okay, my u is going to be to the 1/2 or the square root of u. Yes? And my dx, okay, is getting taken up by 1/7 du. So that's why I said constants are a pretty easy fix if you have extra constants floating. So now what is the antiderivative of u to the 1/2?
U to the 3
Okay.
over 3 or over 2?
Over
Times 3 halves.
over 3 halves,
Over 2.
which is the same thing as multiplying by
2 thirds.
there we go. And then plus u. So I have a 2 on top. 7 times 3 is
21.
and then again, I have to substitute in my original expression back in. Wait. Yes, no, maybe. Now, I don't tend to have one like this up there, but I'll put one on there. So let's say this was very similar, but instead I had x times the square root of 7x plus 9. Let's not do 7x. Let's just do 7x. There you go. Like that. Are we okay with that? Yes, no, maybe? Because again, we asked what would happen if my derivative doesn't match. Yes? Okay. So, my u is still going to be relatively the same, right? It's just going to be 7x. So then what's our du? 7 dx, right? So again, I just divide by 7 and that's not bad, right? But what's the issue then for like this one? So like right now, if I were to substitute this, we have a 1/7, that's fine. This is u to the 1/2 du, but what do I still have hanging out right there? An x, right? That x did not get like scooped up by my du. Agreed? And I don't want an integral with x's and u's because that's not helpful. Yes? But something that we can do is, do I have something up there that gives me a relationship between u and x?
U equals 7x.
Okay, so if I don't want x's and I want to put u's in instead, what could I do with this? Yeah. So like this, I also know then that 1/7 u equals x. Yes. So I have another 1/7 and another u. Yes. So now I have the integral of 1/49, right? Yeah. Well, but then now this is just multiplication. Now I have a denominator or a base of u for both of them, so I can just do what to my exponent? Exponent rules. When we multiply, they have the same base, then I can add the exponents, right? So this is a 1, this is a 1/2. The 2/2 plus 1/2 gives us u to the 3/2. D. And then we can just take our antiderivative like we have been with our power rule. Does that make sense? Now, if there was something that like 1, I couldn't just divide by a constant, or 2, there's not a nice easy way to do this, then u sub is not going to be the technique we would use. We would have to do something else. Does that kind of make sense? But you have to be able to substitute stuff around and get only u's left in order to be able to use u sub. Alright, let's look at another example. What do we have here? We have trig functions, yay! Yay! We can do use sub with trig functions. So on this one, what do we want to do? What's our inside stuff?
5x.
Cool. So then what is our du?
5.
Okay. Do I have an extra 5? No. So we do have to add in a 1/5. But then, what is the antiderivative of cosine of u? Positive?
Negative. Positive.
So the derivative of a positive sign is a positive cosine. Let's see. And then I just substitute my 5x back in. So this is very similar to the one that we looked at the very beginning, just we didn't have the nice 5 at the front, so I had to take care of that with a 1/5. Yes, no you. Okay, what's different about the second one?
There are 2.
There's 2 of them, okay. So if I did the same u sub here, right? U equals 5x. I would still have a 1/5, that's not a big deal. But I would have sine of u times cosine of u. Did that help all that much? Not really, because there's still 2 of them. Yes? But remember, the second part that I said is not only are we looking for stuff that's on the inside, we're also looking for stuff that has the derivative somewhere floating in there as well. Yes? And what do we know about sine and cosine? Yeah, they're derivatives of each other. So, instead of doing our u as the 5x, I can actually let my u be my sine of 5x. Because then, what is du?
Cosine of 5x.
Times
1/5.
times 5.
Oh, yeah.
Just the derivative of the inside stuff is 5. But I can take care of that by dividing. So now, if I rewrite my integral, what would I get? What do we get?
Cosine 5x times cosine 5x du.
So I shouldn't have any x's left. Because the whole point of u sub is that my integral should now be in terms of u.
1/5 u du.
Yep. Right, because my u, my sine, was my u. And then my 1/5 du is basically taking care of all the rest of it. So as long as I put that 1/5 there and my du, that's my new integral. And now I only have one thing instead of 2 things, and it's not a trig function anymore, which is real nice. So what's the antiderivative of u? But then I have to
Oh,
divide by 2, so I have a 1/2 plus c. So I get 1/10, and then I'm just going to plug my u back in, which is sine of 5x. So notice that the reason that we had 2 things to start with is because this would have been a double chain rule. Because I have a 5x, then I have a sine, and then I have a square. So that's why we ended up with a sine and a cosine in there. Because we would have had to do our fun-filled chain rule for that one. questions do we have there? Great, let's look at one last example. So we've looked at basic polynomials, we've looked at trig functions, now we're going to look at e's. Yes, no, maybe? So what do we want to make our u? Which do we feel like in our heart should be the u?
U to the x.
Just the one on the bottom?
Only u to the x.
So if I let e to the x be u, then the derivative of e to the x is e to the x. So I would have e to the 2x plus 2u plus 1 divided by u. So I don't really want to just make it one.
Make the whole thing u.
What's the whole thing?
E to the 2x plus 2 e to the x plus 1 over e to the x.
I don't want to make the whole thing u. Because then I would have to use a quotient rule in order to take the derivative of that, which is not going to be nice. Other ideas?
Just the top.
Okay, so if I did just the top, okay, what's the derivative of e to the 2x?
2e to 2 e to the x.
2e to the 2x, and then I would still have a plus 2e to the x plus 1. So I also don't have that anywhere.
Just the bottom.
We're going to try that. But right now, how many things do we have in the bottom?
1.
Okay, so what can I do?
Split.
Split it up into
3 parts.
3 fractions. Then maybe we'll have an easier u. Are we all okay with that?
Yes.
So notice that e to the 2x divided by e to the x is just e to the x. 2e to the x divided by e to the x is just 2. And then this last one, we could technically write as e to the negative x in order for us to be able to take the antiderivative. So what ends up happening is that for these first two, I actually don't need u sub. Okay, they're pretty straightforward. What's the antiderivative of e to the x?
E to the x.
What's the antiderivative of 2?
2x.
Okay, now for this last one, I am going to have to do a u sub. So I have not evaluated my integral yet, so I still have my integral symbol for this last part. Yes? These two I've evaluated, so that's why they're outside of it. This one I still have to evaluate. So now what might be a good u just for this last part? Or what's on the inside?
Yes.
Hmm?
Dx. Not dx. Dx.
Okay, but right now the x isn't the issue, it also has a what with it? Not just an x, it's a negative x. So yeah, I want to make the x part my u, but we do have to include the negative along with it. Which means that I get a negative dx. I don't happen to have a negative right now. So I'm going to have to make that a negative du. So this becomes negative e to the u du. So now that I'm actually evaluating this part, I can drop my last integral. It's going to be subtraction, because I have a negative here. What's the antiderivative of e to the u? E to the u, yes? And then we would plug our u back in, so just negative x. And then I do have to put my plus c. And that'll work for like basically anything that you have in your exponent. So anytime I have e to stuff that isn't just x, that's usually what my u is going to be, is whatever's in that exponent.